afternoon. You will need a calculator today. So if you don't have one, go get one. Green arrow. You don't know who that is? I can't talk to you anymore. No. So make sure you have a calculator out today. Calculator, calculator, calculator. All right, before we get started on the new stuff, let's take a moment and look back at what we did yesterday. All right, so I want you to update this title, please, from Trigonometry to Trigonometry Basic Functions. And this way, the title of yesterday's lecture is an exact duplicate match to the worksheet that just came out today. All right, so that way you can find it real easy for yourselves, all right? Again, make sure you pick up this worksheet. It's over there by the calculators. So if you grabbed a calculator or grabbing a calculator, grab one. Otherwise, after lecture, you can scoop it up. Haven't given you a due date on it yet, so finish it as soon as possible, please. And before we continue on, let's look back at the example from yesterday. So this is the work that we did yesterday. We were finding the trigonometric ratios, writing them as fractions, and what we're going to kick off with today is we're going to finish this page by writing the trigonometric ratios as decimals. If you used up the whole page, you can write it on the back of the page. If you still have room on that page, just write it at the bottom. It's not going to take up much room at all. Yes, ma'am?
Can I write it on the side?
You can write it on the side as well, because it's not going to take much at all. Write the trigonometric ratios as a decimal, rounded to the nearest hundredth. I was trying to decide what place value. How many places is that after the decimal?
2.
Hundredth. How do you know? How many zeros does 100 have?
2.
2, so you're going 2 decimal places. And that's the easy trick on how to do that. So if you're asked, how do you know? Just how many zeros would that number have? All right, that's how many places you go. All right. Now if you look back at the work yesterday, the very first trigonometric ratio at the top of the page is sine of theta. Yesterday's calculation gave us sine of theta as 4/5. If you're Ashley, hon, if you're looking for today's work, you might want to grab something other than. Yeah.
Thank you.
Thanks. So put this in your calculator.
0.8.
He said 0.8, but grab your calculator. And please make sure that when you type this, you go 4 times 5, and then you hit Control Enter. Otherwise, it's not going to give you a decimal. Okay? There it is. All right, that's what you got. 0.8, but we want it to the nearest hundredth, so I need 2 decimal places. So add that other 0. I would like you, please, for notebook check number 3 this semester, try to finish it today. I would like you, please, to get the decimal form for all of these trig functions that you did yesterday. I'm going to give you about a minute to make sure that you have your instructions and you know which items that you are doing. Remember, you're using the ones from the example in the top part of this page, which was the example from yesterday. I'll give you about a minute to set up, and then we're going to move on to the example. Yes, ma'am?
Did you already write it down?
We did.
Okay, so it's just right in the...
We're just going to turn those fractions into decimals. And that'll be the notebook check. You should be able to get this done before you go home today. You'll be given some more time after lecture. If you were out yesterday or are missing it, you can grab one of the notebooks from yesterday. Update those notes. Grab those values. and then write the decimals. Giving you about 30 more seconds to work. All right, we'll look at this again at the end of the class. I'll just swing by your desk, check to see that you have it, or you can call me over, and I'll be happy to give you that extra 100. Goes into the grade book for this grade period, so please make sure you get this section done, all right? All right, here we go. Let's start with the new items for today. Actually, new items is a bit of a misnomer, because all the things that we're going to do today, you've already done. We're going to stay Chapter 8, Lesson 4. We are doing trigonometry, but this time we're going to look at trigonometry through the lens of some special right triangles. And so if you have been stuck with figuring out how the special right triangles work, hopefully today will help clarify that a little bit more for you, and you're going to end feeling a little more comfortable with it. Please do give a new title and write a new objective. Yes, our what objective is still the same. You are still going to write trigonometric ratios. Trigonometric ratios. But the how has changed a little bit, because how we're going to write them is by using special right triangles. And so let's start off the day with a recall of our special right triangles. What are our special right triangles? The 30, 60, 90 is one of them. And 45, 45, 90 is the other one. Okay, so in these two spaces, all I've done is cut my little right-hand workspace into two pieces. Draw right triangles in both of them. Make one of them a 30, a 60, and a 90. Remember that those are angle measures. And make the other one 45, 45, 90. Again, 45, 45, and 90, those numbers are all angle measures. All right, so looking back at these special little glyphs that we've been using, they showed up a few days ago. We're going to look at the 45, 45, 90 first. What this glyph has written and what it means is that whatever the measure of one of the legs is, both of those legs are going to have the same measure. And I'm going to use X because I don't really know what number I'm going to see there. But whatever number I see there, the hypotenuse is that number times the square root of 2. Okay? Don't overthink it. Don't stick in your calculator and try to give me decimal numbers, because you're going to be here for the rest of eternity writing numbers. You have better things to do with your life. Please just leave it as the square root of 2. Okay? Now, the 30, 60, 90 requires you to look at the side opposite the 30-degree angle. That is your reference side number. Whatever value that side has, the hypotenuse is that value times 2. This leaves the other side, the medium one, the one across from the 60, to be this number here, the shortest side across from the 30, times the square root of 3. This is the pattern that we're going to be using today. Hopefully giving you a little more practice and a little bit more insight finding the sides of those values. I know that some of you are still having trouble because there's still a lot of assignments 8-3 out, which is where you had to do this over and over and over again. Okay. Let's go ahead and do our example. The directions for our examples are going to say, write the trigonometric ratios as a fraction and as a decimal, but this time please round it to the nearest thousandth. So how many decimal places are you going to have?
3.
3. Why is it 3?
Because 1,000 has 3 zeros.
Because 1,000 has 3 zeros, and so you're going to give 3 places after the decimal point. All right, let's draw our first figure. We're going to have a triangle that looks something like this. And let's do this. And I'd like you please to find for me the tangent of 45 degrees. This already looks different than the ones you've been given before. All the others I've said find the tangent of theta or find the tangent of, and then I name some angle. This time I've given you an actual angle measure to find the tangent of. But look at this triangle. Don't we have a 45-degree angle marked? Yeah, this one. This angle appears also 45-degree, even though it's not marked. But because, look, they're congruent, this one's also 45 degrees, yes? So either one of those can act as your reference angle. Which one do you want to be your reference angle? The marked one or the unmarked one?
Marked.
The marked one. So he's going to use this as our reference angle. Looking at this as our reference angle, it means that this side is the opposite side. This side is the adjacent side. And while we're labeling stuff, I might as well label this my hypotenuse. All right, according to our notes yesterday, what is the ratio that generates the tangent? The opposite side over? Reading the definition, the ratio is opposite to?
The side that's adjacent.
Adjacent. All right, so come back into yesterday's notes real quick here on the left-hand side, and let's do an abbreviation for you. Opposite over adjacent. So now the next time you're trying to figure out which sides, you can just look here. So now the next time you're trying to figure out the tangent, you can just look here and say, oh, this is the side opposite over the side adjacent. Whoops. Zoomed the wrong way. All right, so what is the value of the side opposite this 45-degree reference angle? I don't have one. But I can find one. This is a 45, 45, 90 right triangle, is it not?
Yes.
And when I have this, it tells me that this hypotenuse is the value of the leg times the square root of 2. What number am I multiplying by the square root of 2?
8.
I'm multiplying 8 by the square root of 2, and so my legs are 8. Do you want to see the algebra on that worked out? To see where I got that from? Yeah? Okay. I've got a few small nods. If you don't need to see it and you're feeling comfortable about where that's coming from, go ahead and get ahead of me for a little bit and find the sine and cosine of 45 degrees while I run the algebra for those who want to see it. Okay. So the hypotenuse was given to me as this value, 8 times the square root of 2. but in my reference, in my little template over there, at the top of the page, I'm told that the hypotenuse is x times the square root of 2. And that x is playing the part of one of the legs measurements that I have in my triangle. And so this problem becomes a solve for x sort of thing, so that I can figure out what the length of the leg is. What's happening between the x and the square root of 2? It's being multiplied. How do you undo multiplication? Division. What am I trying to get rid of? The square root of 2. It's in the way, so I'm going to divide by the square root of 2. Okay. I know this looks really bizarre, but you're going to do a lot of this sort of stuff moving forward in the other math class you're going to be taking in high school and through college, and so I'm hoping just to kind of get you familiar with it. What is the square root of 2 divided by the square root of 2? It's 1. So these basically cancel out. And the length of a leg is 8. So those of you who wanted to see the algebra on it, give me a quick subtle nod if that helped out. All right, thank you very much. Awesome. All right, what was the ratio, tell me here, for tangent? You told me opposite over adjacent. So the measure of the leg opposite, 45?
8.
8. And the measure of the leg adjacent? 8. And 8 divided by 8 is? 1. Don't forget to write that as a decimal. 1.000, however many zeros you need. All right, let's do tangent of 45 degrees. According to your notes from yesterday, what is the ratio that generates sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So let's flip into yesterday's notes really quick and put that shortcut for ourselves right here on the left-hand side. Opposite over hypotenuse. What is the measure of the side opposite the angle 45?
8.
8. What is the measure of the hypotenuse?
8 times the square root of 2.
8 times the square root of 2. And so you should have a fraction that looks something like that. We have to reduce this fraction. How do I do that? The 8s would cancel because it equals 1, and what would you be left with?
1 times the square root of 2.
1 times the square root of 2, or 1 divided by the square root of 2? And how do you know which way is which? Let me show you a trick on this. When you're looking to reduce fractions like this, you have to think to self, what is the greatest common factor between 8 and 8? Well, it's 8. 8 is divisible by itself. It's going to give you 1 every single time you do it. So if I divide this top number by 8, I'm left with 1. If I divide this bottom number here by 8, I'm left with 1. I'm not doing anything to that square root of 2, and so I'm left with 1 over 1 times the square root of 2. But what's 1 times anything? Yeah, itself, it doesn't change. And so I end up with 1 over the square root of 2. Don't forget to give that to me as a decimal, rounded to the nearest thousandth. 3 decimal places, please.
How would we do that? Just calculator?
Yeah, calculator. Go to your handy dandy calculator. Do 1, division sign, square root 2. Enter. Round it to 3 decimal places. It's done.
0.707.
0.something. That what the calculator says, because there was too many numbers. I got lost. All right. According to notes from yesterday, what is the ratio that generates a cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So on the left-hand side, give yourself your little cheat sheet right here. A over h cosine over hypotenuse. Write that in here. Substitute your fraction.
Can you split
Write the reduction of your fraction. Then write it as a decimal. Notice I've left a lot of blanks for you. Can you guess what's going to happen? All right, finish that out. I'm going to go ahead and move on to the next example, and I'll give you time to go back and fill in those numbers for yourself. Set up for a 30, 60, 90 right triangle, please. And let's make the hypotenuse 10 square roots of 3. According to our template, our hypotenuse is worth what kind of value?
10 to the square root of 3.
That's according to this right here. What about according to our template at the top of the page?
Oh,
According to the top of the page, the
Oh, x times
hypotenuse
2?
is x
Or-
times 2 or 2x, where x represents the length of which side?
The adjacent.
The shortest side, the one opposite the 30-degree angle, adjacent to the 60-degree angle. There's a lot of different ways you could say this. All right. What then would be the value of x, the shortest side across from the 30? What would I need to do to solve this equation here for x?
Divide.
Divide by?
2.
By 2. So if I divide both sides by 2,
5 times square root of 3.
10 divided by 2 is 5, and we're not touching the square root of 3 at all. Make sense? All right. According to your reference table on top, what is the measurement of the side across from the 60?
X times the square root of 3.
X times the square root of 3. What is the value of x?
5.
5 what?
5 times the square root of 3.
5 times the square root of 3. And we have the square root of 3 again. That looks weird. Let's multiply them together. How do you multiply radicals? Do you remember how to multiply radicals? You put it under one radical and then you multiply these radicands together. 3 times 3 is? 9. Now we're going to figure out what the square root of 9 is. 3. 5 times 3 is?
50.
And now we have the short side, the middle side, and the hypotenuse. So far, so good? All right. For your notebook check number 4, not only will you be completing this top portion right here with the cosine of 45 degrees, both the fraction, its reduced, and its decimal, but you will be writing down for me, let me change colors here, the sine of 30 degrees as a fraction, simplest terms please, and as a decimal to the thousandths. A lot of bleh. 3 decimal places.
So like the top one.
Just like the top one. You're going to find the sine of 60, fraction reduced please, and the decimal. You'll be finding the cosine of 30 as a fraction and as a decimal. You'll be finding the cosine of 60 as a fraction, as a decimal. You'll be finding the tangent of 30 as a fraction, as a decimal, and the tangent of 60 degrees, fraction, and decimal. Please make this notebook check due no later than tomorrow. So you can use whatever time you have today, or you can take it home and finish it out for homework. I will check it again tomorrow. After that, I'm going to start putting a few late points on it. Okay? All right. Any questions on what we were doing today? The rest of the day is yours. Thank you very much.